Hello everyone and welcome to Rationalizing the Denominator. One of the important things in math is you are not allowed to have a radical in the denominator. So if you look at question number 2, we have a root 3 in the bottom. The only way to get rid of a root 3 in the denominator is to multiply the top and the bottom of the fraction by root 3 again. We discussed in class today that when you multiply root 3 times root 3, you get a plain 3, and in the numerator you would simply have a 2 root 3, and that would be your answer. So whenever you see a radical in the denominator, you want to multiply the numerator and the denominator by that same radical. So what do you think on number 3 we're going to multiply the top and the bottom by? We're going to multiply by root 7. So in the numerator you have a plain root 7, because 1 times root 7 is root 7, and a root 7 times root 7 is a plain 7. Notice in both questions 1 and 2, originally we had a radical in the denominator, and now we don't. So that's the whole point of rationalizing the denominator. Let's take a look at the next couple of questions. So on number 4, we're going to multiply the top and the bottom by root 2. And here we would have 6 root 2 over a plain 2. Now most kids would think you were done there. However, you're supposed to reduce the 6 and the 2 to make it a 3 and a 1, and our final answer is 3 root 2. So please make sure you don't forget to reduce. The next one, we're going to multiply the top and the bottom by what number? By root 5. So we wind up with 15 root 5 over plain 5. And notice we're well on our way to rationalizing the denominator because there's no more radical down there. However, we're not finished. We have to divide out the 15 and the 5. So that cancels out and becomes a 3 and a 1. And my final answer is 3 root 5. And that's the correct answer. All right, the next one. Take a second. What do you think we're going to multiply the top and the bottom by? We're going to multiply the top and the bottom by root 7. So take a second and simplify that, please. 42 root 7 over plain 7. And at this point, you should realize that something reduces. The 42 and the 7 are going to cancel out and become a 6 and a 1. And my final answer, 6 root 7. Very important that you simplify whenever you can, especially when something can be reduced. So, number 7. We're going to multiply the top and the bottom by root 81 over root 81. And you're going to wind up with root 81 over plain 81, which actually reduces into 9 over 81, which is equal to 1/9. Now, the interesting thing about doing it that way is there was a shortcut on this question. 81 is already a perfect square. So if you wanted to, you could take the square root of 81, which is 9, and leave it in the bottom of the fraction. So the correct answer is 1 over 9. If you have a perfect square, you don't need to rationalize. You can actually just take the square root of the number. Okay, number 8. So we're going to multiply the top and the bottom by root 11 over root 11. And I wind up with 2 root 11 over 11, and then nothing can be simplified, so that's my final answer. Okay, number 9. We have 4 over root 2. I'm going to multiply the top and the bottom by root 2 over root 2. 4 root 2 over plain 2. And when I simplify the 4 and the 2, I wind up with a 2 root 2, and that's my answer. Okay, just 3 more questions. So now, if I look at number 10, I multiply the top and the bottom by root 3 over root 3, and I wind up with root 3 over plain 3. Nothing can be simplified. I am not allowed to cross out the 3's because one of them is in a radical and the other one is not. So I'm finished. Number 11 is very, very similar to question number 7. Notice the 225 in the denominator, this number right here, is in fact a perfect square. So 1 over 15 is my answer. And then the last one, also like the last two examples, radical 16 is a perfect square, so it's actually 1 over 3 times 4, and my answer is 1 over 12. Okay, so again, rationalizing the denominator, you want to multiply the top and the bottom by the radical so that it goes away. Thanks, and I'll see you tomorrow.